All right. Transformation 4 out of 4. Okay. We're dealing with dilations. You know how every week I've talked to you about rigid motion? Okay. Can anyone tell me what a rigid motion is? Doesn't change the size or the shape. So every transformation that we've seen so far, they have been rigid motions. Okay. So is a dilation a rigid motion? Why not? Because it changes the size or the shape. Okay, so dilation, first thing I want you to write, it is not a rigid motion. And again, the reasoning is because it changes the size of our shape. Okay, so this is the only transformation that we're going to talk about that is not a rigid motion. So there are two types of dilations, okay? What do you think they are? What are two different ways the shape can change? Yes, what did you say? Right, it's the size that it's going, right? It's either getting bigger or it's getting smaller. So what we're going to call it for getting bigger, that's going to be an enlargement. So if our shape gets bigger, that's called an enlargement. Okay, what's the other option other than getting bigger? It gets smaller, it shrinks, okay? What's a word for getting smaller other than shrink? Starts with a R. Reduce in size, it's called a reduction. Yep. Okay, and again, reduction means gets smaller. Okay, so we're going to be dealing with those two types of dilations, an enlargement getting bigger and a reduction getting smaller. Okay? Okay, now we're going to talk about something called a scale factor. Okay, the scale factor tells us whether we're going to be doing an enlargement or a reduction. Okay, so for scale factor, I'm going to call that S, just for short. So if our scale factor is greater than 1, what do you think is going to happen to our image? If our scale factor is greater than 1, what do you think? It's going to get bigger. Yep, it's going to be an enlargement. Okay, so if our scale factor is greater than 1, it's going to be an enlargement. You could see this as like other whole numbers. Okay, you could even see it as fractions. However, this is greater than 1. Do you agree? Okay, if I typed that in my calculator, that would give me about 1.5. Is that greater than 1? Yes. Okay, so decimals and fractions also work in this. Okay, what if my scale factor was less than 1? It's going to be a reduction. Yep. So for the scale factor being less than 1, we're going to stick with positive numbers here. So less than 1, that could be 1/2, 1/4, 2/3. Okay, we're going to stick with numbers greater than 0. Okay. And then if S equals 1, what would happen? It doesn't change. It would stay the same. Okay, so if I asked you to perform a dilation with a scale factor of 1, would you have to do anything? No, you would not. Now we're going to talk about actually how to perform the dilations, okay, using the scale factor. So how to perform the dilations. We are going to take our pre-image, okay, which a lot of the time we say old, okay, pre-image times our scale factor. And that is going to equal to give us our new image. Okay, so again, a lot of the time for pre-image, we say old, image, we say new. So pre-image times the scale factor gives us our new image. So let's look at what this looks like with coordinates. Okay, so if I have my original XY coordinate, and for the dilations, we are going to take that original XY coordinate, we're going to multiply it by our scale factor, S. Okay, and then that's going to equal to give us our, I'm going to call it X prime, Y prime. What do those prime symbols mean? It's the new image, right? Okay, so the way we're going to multiply this out, okay, what do I mean by distribute? What do I mean by distribute? So you do not have to write this down, but if I had this written in this form here, how would I distribute that S in? Oh, a lot of you are going like this, right? Exactly. We're going to multiply it by X, and we're going to multiply it by Y. Okay, same thing with how this is set up. Okay, we're going to take S, we're going to multiply it by X. We're also going to multiply it by Y. Okay, that's what's going to give us our new X prime, Y prime coordinate. Okay, so it's distribution going on. All right, and then last thing we're going to talk about is writing the rule for the dilations. Okay, so just like we did for the other ones, we are going to have to go backwards and have to write the rule that's happening. There's going to be two things that we need to worry about. Okay, one, we need to know what's happening, so whether it's an enlargement or a reduction. So the first thing, you need to state whether it's an enlargement or reduction. Okay, and then what do you think the second thing we need is? The size, right? We need what that scale factor is. Okay, how much it's getting bigger by or how much it's getting smaller by. Okay, so two things we need for that rule. We need to know if it's an enlargement or a reduction, and then what the scale factor is. Okay, with these dilations, do you think it matters which one you start with? Do you think it matters if I start with the old image or the new image? Why does it have to be the old?
You get the opposite.
Right, it's kind of the same thing with translations, right? If we start with the new, we're going to get opposite of what we should have gotten if we started with the old. So make sure we're starting with the correct image first. Okay? One little note I want to make before we get into this a little bit. Okay? Go ahead and make yourself a little note here. Start it. Okay? Every dilation we do is going to be centered around the origin. Okay, again, what do I mean by origin? 0, 0, the middle of the graph, right? So just like the rotations, okay, all of this is going to be centered around the origin. Okay. Okay. First thing I want you to do in your groups, on 1 through 4, talk, is it going to be an enlargement or a reduction? On 1 through 4, go ahead and talk about it. All right, what's number 1? It's an enlargement. Let me zoom in a little bit here. Yep, it's an enlargement. Because why?
The number is greater than 1.
The number 2, our scale factor, is greater than 1. Okay, what about number 2? Reduction. Okay, a lot of the time we might want to, it might be easier to work with decimals. Okay, so I'm going to work with 0.25. Okay, it might be a little easier here. So that one is a reduction because it's less than 1. What about number 3? It is a reduction, again, because why? Less than 1. Okay, again, I can use 0.5 for that one. And then number 4, what is that? That one is an enlargement. Okay, I'm going to take us back to number 1 here. Okay, we're going to actually perform this. Okay, with these, we want to find our original coordinates first. Okay, so what are my original coordinates for G? What are G's original coordinates? 0, 2. 0, 2. What are H's original coordinates? 2, 1. And F, what's its original coordinates? -2, -2. Okay. Now, for a dilation of 2, how do we find our new image? What do I do with all those coordinates? Multiply all of them by our scale factor of 2. So if I multiply by 2, okay, remember we're distributing here. What's 2 times 0? 0. What's 2 times 2? 4. So our new point for G prime is 0, 4. Okay. Do the same thing for H and F. I'm going to multiply by 2 to H. So H prime is going to be what? 4, 2. Okay, and then same thing for F. What are F prime's coordinates going to be? -4, -4. Good. Okay, and then once you have all 3 points, go ahead and make your new image. Let's talk about real quick how we can check these, okay? To check if we did it right on number 1, what did we say right at the beginning should happen? An enlargement. Is that what happened? Did it get bigger? Yes. Okay, so you can use that to check. Number 2, okay, we want to find our original coordinates first. What are Q's coordinates? 0, 2, R, 1, 1, thank you. S is 3, 1, and P is swap that. -2, -1. Yep. Again, I don't care if you use the fraction or the decimal. I think it might be easier to use the decimal. Okay, so I'm going to multiply all of these by 0.25. Okay, what's 0 times 0.25? 0. What is 0.25 times 2? Should get 0.5 on that one, right? Okay, so with these, do you notice how our points are not going to be perfect? Okay, because we have a 0.5 in there, right? So you got to guesstimate a little bit. I'm going to guess my Q is going to end up right about there. Okay, do the same thing for the rest of them. So your R prime, if I multiply those, you should get 0.25, 0.25. Okay, same thing for 3. Okay, my point S, I know some of you are working. Look at my point S here. What do you notice about it? My new S, S prime. Where did it land? Notice how it landed on the original image? Remember, that's fine because where are we centered around? We're centered around the origin. Okay. Here, 0.25. So P prime is going to be -0.5 and -0.25. Okay, so here's our new image. Okay, again, do your best as to where those points should end up if they're not going to be perfect points. Okay. How can we check if we did this correctly? If it got smaller, right? At the beginning we said reduction. Is that what happened in our picture? Yes. So jumping down to number 5. Okay, this time we want to write a rule. What were 2 things we need to write a rule? If it is enlargement or reduction is 1, what else? The scale factor. Okay, so let's look at this here. I know yours isn't color-coded, so which one is the old?
The smaller one.
How'd you know?
Because
Doesn't have prime, right? So this one's my original, this one's my new. What happened?
it got bigger.
It got bigger. What's that called?
Enlargement.
Yep, so enlargement. Now we need to know by how much. Okay? How'd you figure that out?
I looked at it, and one of them is 4, and the other one is 2, like K. It's over 4, and the new one, the old one's over 2.
Okay, I want to give you a little trick here. Okay, I want you to use this trick if you can't visually see that, because a lot of the times we might have fractions as our answer, so it might not be as obvious. Okay, so what I want you to keep in mind is new divided by old. New divided by the old. Okay, because if I'm at the beginning to perform these, we were multiplying, right, to get our new image. So to get back, we need to divide to find out what happened. So you can pick any of the points. Does it matter? No, why not? It doesn't matter, okay, because they all should be what? They should all have the same scale factor. Okay, so I'm just going to pick K as, actually, I'm going to pick J. I'm going to pick J as an example. So J prime, what are J prime's coordinates? 0, 4. what are J's coordinates? Original J. 0, 2. Okay, so we want to divide these. But notice, can I take 0 divided by 0? No, because that would give me 0. Does 0 make sense? No. Okay, so if I take 4 divided by 2, what's our scale factor? 2. So our answer is an enlargement by 2. Okay. Cool. What I want you to do here, just to get some individual group practice, go ahead and do the 3 that we did not do together. Go ahead and do 3, 4, and 6. Number 3, we said it was a reduction. Again, I don't care if you keep it as a fraction or write it as a decimal. Either way is fine. What do I need to find first, though? What? The original points, right? So V is what? Negative 1, 2, W, 1, 1, and U, negative 1, negative 1. So what do I do to each of those coordinates there? Multiply by 0.5. Okay, V prime, what is its new coordinates if I distribute this?
Negative 0.5.
And 1, yep. And then label your coordinates. What are W prime's coordinates?
0.5.
Yep. And then U is
Negative 0.5. Negative 0.5.
good. Here, and then label your coordinates and draw your picture. Okay, to check, we said reduction. Did it reduce? Yes. Okay, number 4, enlargement here. What are D's original coordinates? 0, 1, E, 1, 1, F. Flip that. Yep, 1, negative 1. What am I multiplying by every single time? 2, because our scale factor in the direction says 2. D prime, what are his coordinates, his or her? 0, 2. So D prime ends up here. What about E? 2, 2. And then F prime is 2, negative 2. Ends up here. Again, we're centered around what? The origin. Okay, so all these dilations are happening around the origin. Any questions about performing the dilations? All right, last one we're going to talk about is number 6. Okay, what do we need to figure out first?
Coordinates.
Could help with that. Let's figure out if it's an enlargement or reduction first. Which one? It is an enlargement. Okay, now we want to know by how much. Find our scale factor. What's the trick that I shared with you? New divided by old. Now, if you picked M, what do you notice about M? It's not like a nice point, right? It's not on a perfect coordinate there. So I would pick the one that's on perfect coordinates so you don't have to worry about decimals and all of those things. Okay. So which one should we choose? L. Okay, so L prime, what are L prime's coordinates? 0, negative 3, right? What about original L? 0, negative 2. Okay, does it help to take 0 divided by 0? No. Okay, what about negative 3 divided by negative 2? Yeah, I would accept 3 over 2, or what does that go to? 1.5. I would accept both of those. Now again, even though this turned out to be a fraction, it was greater than 1. So it's still an enlargement there. Okay. Again, check your answers. Okay. We said it should be an enlargement, so this number should be what? Greater than 1. Okay.